continue talking about views by looking at base views or basic views. So a base view is a representation of the table itself that you're querying, and it's going to be on one table. So the idea is that you want to force people to use your view to see the table data and not allow access to the table. So you create a table, then you create a basic view or base view, and then you restrict access to the table using those deny statements I showed you earlier, while allowing access to the view by using the grant statement. And this forces people to use the data in your table in the abstract, not directly, but through an abstraction layer. So code might look like this. I create a table called TBL for table customers, and then I create a view. If you name the table customers, you can't name the view customers, so you need to have some kind of identifier. And sometimes people, like myself, will put a V to let people know they're saying a view in front of the view name. But other times what they'll do is they'll put TBL in front of the table name, and then on the view, they'll just put the name of the view. And people will often think that they're using the table directly, but they're not. They're using it indirectly. Now, where this works is that for every column in the table, you identify that column in your view select statement. You want a one-to-one match. So all the columns in the table are going to be directly matched in the view. And the idea, of course, is that when people select all from the view, they see the data in the table. Remember that a view never saves the data anywhere. The view is just a save select statement. But what you're seeing is the data that is returned from the query. And this is how we use a base view or basic view. Now this abstraction layer makes hiding changes in a database a little bit easier. It makes it so you can make changes in a database easier. If you've been a professional for any length of time, you've all heard the statement that we can't do that because it would mess up the database. We can't make changes to the software because it would mess up the database, or we can't change the database because it would mess up the software, etc. This has always been a problem because over time, changes are going to happen in the way you store and structure your data. But by using these abstraction layers, it makes it a little bit easier to make changes to the table's design. And this is a real good idea because it's really easy to do. So let me give you just a simple example. It's probably not the best example, but it's simple enough. Let's say that I have this table, and currently the customer's name is in first name and last name combined. Then I find out that I really don't want that. What I really wanted was a first name column and a last name column, so I really want to change that. However, let's say that the people that wrote a web application actually tied directly into the table. If I were to change that table, the web application would break because there would no longer be a single customer name column. That is a problem. And that means that you can't change the database because it would break the web application or windowed application or whatever. That happens all the time. However, let's say the people that made the web application actually used the view. You could change the table as long as you made it look in the view like nothing had changed. So what I might do is this. I'd copy all the data into a little temporary table. I'd drop the original table. I'd remake the original table, putting in a first name and last name. I would then copy the data back from the temporary table into my new table by dividing the first name and last name into two different values. And now I have the new version of the customer's table filled up with last name and first name in 3 columns instead of 2. Now again, that's not going to work for the view because we have to change the view in order for it to match the table. So what we do is we go and we modify that view and make it so that it concatenates the first name and last name together into a customer name column. This is the column alias. And when people use the view, it's like nothing had changed. Nothing has changed at all. We had never normalized that data into 2 parts. Of course, I'd make another view, a newer view, customer V2 or customer normalized or whatever name you want to call it. And that new one would represent the new version of the table. Now, this means that the applications that were built on the original design keep working as they always have worked. Any new applications should point to the new version of the view. And of course, you want to force people into using the view by denying access directly to the table and granting access only to the view. And that way, when the web developers try to query the table directly, they are denied access. But if they try to query the customer's view, they are granted access, and so they can do so. And the fact that it has no V there, maybe they don't even know that they're using a view. And sometimes that's kind of nice, and sometimes it's a little misleading. I'll let other people decide what that should be. I myself like to be a little bit more transparent. Anyway, so that is a basic view. And the idea is that in every single database that you make, you should always have for every single table an actual base view to represent that table. Deny access on the table, force the users of your database to use the views instead, and that'll make changes over time much simpler. You may never change the table, but if you do, the view is cheap insurance. Like all insurance, you hope that you never have to use it, but when the day comes that you do, you're glad you have it. Another use of a basic view is to stop changes from occurring in the database that may be done by mistake. One way you can do this is to bind the design or schema of the view to the actual table. Now, you can drop a table even if you have a foreign key. It's possible to drop that. You can drop the foreign key constraint, you can drop the table, and that means that by mistake, if that table dropped, all those columns and the foreign key columns, like let's say we have products and order details in Northwind, if I were to drop products, then all the information and the order details about the product IDs would be useless. So that's not a good thing. You don't want tables dropping by mistake. So what people do is they will sometimes make a basic view have a schema binding option. So you make a view like this one, view categories, you put in the with schema binding, and it does a couple things. First of all, it can't drop the table without you getting an error message. The schema binding stops that from happening. But they also can't do things that like change the table names, change the column names. They can't drop the columns. It has to look the same once it's bound to the table. And so that protects you from making any changes to a table that would basically break the view. So that that is a useful feature, and it's pretty easy to put in there. The name looks a little weird, schema binding, but schema is another word for design. So with schema binding is with design binding. And one other thing that's a little bit odd, they force you when you use this command to use the two-part name, the namespace typically of database owner in Microsoft SQL Server, and the name of the object or table you're binding it to. Now, once you're done with that, again, if you try to alter the table, like let's say I want to add a column in, oddly enough, when you add a column, alter table and add a column, you don't use the word column. You would think it'd be alter table, add column, but you don't. But you can see that the column showed up. Now, there was nothing, it was a new column, so any rows I previously had just got filled up with nulls right now. But of course, it didn't change the view. The view continues to work. However, if I were to drop the category name column, which would actually break the view, that will be a problem. And it would say you can't do it because it is dependent on the column name in that view. So this is a way to protect your views from becoming, as they call it, orphaned by the actual parent object. And again, it's pretty easy to do. The only thing you have to do is put in with schema binding and then the database owner. Now, you can do this on a reporting view. Sometimes people do, but on a basic view or base view that represents the actual table, I think it's always a good practice. So whenever you make a base view, I recommend you put in the with schema binding if that option is available in the database product you're working with. Also, notice that I can't drop the entire table. So if I try to drop the entire table, it won't work. I can alter the table and drop the foreign key constraint, then try to drop the table, but that's not going to work anymore. Without that schema binding, it would work and the view would be orphaned. But with the schema binding, you can't do it. Now, of course, you could just delete the view and then drop the table, and that's perfectly fine. But it's just one more step that people have to make so that they don't make a silly mistake such as dropping a table. So often you'll see a base view for every table, and even if they do nothing else in that with that base view, they'll have schema binding in there just to slow people down from making silly mistakes like dropping a table that's needed. Next up, we'll take a look at functions, how to create your own custom functions that are very similar to View. I'll see you there.